Uh, let's get started with another new problem, and this is word search 2. So let's read the description. Given an across and board of character and a list of string words, return all words on the board. Each word must be constructed from letters of sequence adjacent call where adjacent call are horizontal or vertical neighboring the same letter shall may not be used more than once in a word. So this question is saying that we have given a board and we need to check whether we can form the word, these word that is present in this string words, array of string, and if we are able to form this word using this table, then we need to return those combinations. Let's get started with coding. For this problem, we are going to use trie. So we will use concept of childNode. So basically, childNode is based on prefix. So let's create a static class. So childNode. So inside childNode, we will take two parameters. First will be string word, that is, let's say null, and second will be children, which will contain key as character and value as trie_node itself. Map, let's say children, new hash map. Now, first of all, we will construct a trie, then we will use simple DFS. Let's use it. Say root, and we will traverse through the word, and then for each word we will traverse through its character as well. For character say in word.to char array, we will say if node dot children does not contains key as the character, we will make a new trie node object. We will say trie node new node new trie node. Now and now we will update the value. We'll update with new node into the existing node. Else, if the key is already present, then we will simply fetch the value node dot children dot get character and update the value of node with the new value. In this way, we have formed our so in this way we formed uh, our try. Now we will use so here for loop is matching and the for loop is exiting here and this one is exiting here. Here we will update our word. So we will say so is it matching this? If so, we will update our node dot word, that is this word. We will update with this word. So node in node dot word we will put our word. So this is the outdated try. This is the first step. Now second step will be to use the DFS. For that I will create a direction. Let's say int direction is equal to new int up, down, left, and right. So I made a mistake over here. So it should be 0, comma minus 1, that is left. So our direction is complete. Now we will create a global variable. Let's say board. So we have created our board and we will update this board with this board. So after this, we can say this dot board, board which is present. Now we'll traverse through each character, that is each character here. We'll go through each character and we will check if we are able to form the character or not. So let's say for int I is a row, I should be less equal to 0, I should be less than board dot length I plus plus. For int j equal to 0, j should be less than board at 0 dot length j plus plus. So we will say if root which is this trie node dot children dot contains k board I comma j. So we are basically saying that if the root of the children, that is, if the root of trie node contains one of this character, if we are going through this or this, such as OA, if root contains only, then we will go through DFS. That is, we will go inside it. Otherwise, we will leave it because with the help of E, we cannot form. If we go here, can we form it? Let's consider F. With the help of F, we cannot form any word. So we will skip it. That's what we are doing here. So we will say DFS, let's say row, comma, column, comma, root. Now let's create a method that will be our DFS. Let's say void DFS into row into column and create we will create an object of trie node. From here we can see trie node and let's say root. So we'll say character C is equal to board. Let's say this dot board into row column. Now we will say root dot children dot get this character and this will return what? A trie node itself. That is, we are basically going through each neighbor. Now we will say if node dot word is not null, if value is present in the word, it is over here. You can see if the value is present, then we will update our answer. Answer dot add the node dot word and we will reset the value of word as null. Now, after this step, we need to add a breakpoint. Let's add a character. We can use any character. So for that, let's use dollar. So this is basically a breakpoint. Now we will go through each directions. For that, we'll say for int array in direction. So dir in direction int new row array 0 plus row int new column array it 1 plus column. Now we will check if new row is less than 0 or new column is less than 0 or new row, let's say new column is equal to this dot board at 0 dot length or new row is equal to this dot board dot length, then we will skip, means we will continue. Otherwise, if node dot children dot contains key this dot board enter row comma column, if this node contains the next contains the key at the current index, then we will recursively call it. So we will update our row with new row and column with new column and root with current node. So once we go outside of this for loop, then we will update the character as well. This dot board row column, it should be character, and then we will update it. If node dot children dot is empty, if map is empty, it means that if we left with no value, that is the leaf node, then we can say root dot children dot remove the character. So with the help of this, we are ready to go. We need to create one variable. For answer, we'll copy this. Answer is equal to new array list and we will return it. Return our answer. Let's try to submit it. So there are a few errors and row which symbol length, so we missed. Let's update it. Did we miss something? So I have to I need to check that thing what we are missing here. So here we forgot to update the value of row and column. Let's update the value of row with new row and column with new column. Let's try to run it. Finally, our code got accepted. Let's try to submit it. So our code also has been accepted, means submitted. Thanks for watching.